Hello, welcome back to our Java programming series. In our previous session, we laid the groundwork by exploring arithmetic operators, variables, and data types. If you haven't caught up, the link is in the description. Today, we are taking a deep dive into the crucial aspects of Java operators. These symbols empower us to manipulate values and execute various operations within our code. Before we plunge into the details, let's do a quick recap. We have been talking about arithmetic operators, which are addition, subtraction, multiplication, and division. And they have been serving as foundation to know what Java programming is. Now let's extend our knowledge by exploring new realms, including relational operators, logical operators, assignment operators, and some more operators. Let's start our lecture with relational operators. Okay? Relational operators are symbols that allow us to compare values. They are a crucial aspects of decision making in programming. The most widely used relational operators are greater than, less than, equality, less than or equal to, greater than or equal to, not equal to. Okay, these are most commonly used relational operators. In order to know how they work, how they compute, let's take some example. Let's define two variables x and y as integer. Okay, let int be 12, it's random number. Int y be let's say 18. Okay, now let's use different relational operators to compare between these two values. For that, I will use system.out.println. So here, let me compare x greater than y in the first case, for instance. In the second case, x less than y. In the third case, x is equal to y. In the fourth case, x greater than or equal to y. Another case, less than or equal to y. Okay, and one more case, x is not equal to y. Let's run this one. As you can see in the bottom left corner of this IDE, the result of relational operators is a Boolean type value. Either it is false or true. So x greater than 12 for the first statement, for instance, 12 greater than 18 is false, as you can see here. Again, for the second one, 12 less than 18 should be true. So the same is true here. 8 is equal to, 12 is equal to 18 is false because 12 is not equal to 18. The same is true for all. For instance, if you see the last one, x is not equal to y, which is true for the last case. So this is how relational operators perform computation. Their throughput or their output is basically a true or false value because their purpose is to compare between operands. The second types of logical operators, in addition to the previous arithmetic operators and the current relational operator, is logical operators. Okay, so basically logical operators are AND operators, OR operators, and NOT operators. And in terms of Java, we can write AND as 2 ampersand, okay, OR as 2 bars, and NOT as exclamation. Okay, so before diving into the programming using these logical operators, let me remind you some basic logic operators for inputs A and B. Okay, so let's say we have AND, OR, and NOT. Not B, for instance, for this one. Let me comment this one out. So assume A has 0 for the first round, B has 0, and again, A has another 0 here. Okay, now we have two inputs, each of them having either true or false value. So we compute the logical correlation between these two inputs by using different logical operators like AND, OR, and NOT. In the first scenario, for instance, we use AND. In case of AND, as you remember, the value or the output of an AND operation will be true or 1 if and only if two operands comprising the equation or the expression are true, or two of the operands constituting the equation or the expression are 1. So otherwise, it will return 0 or false. So 0 and 0 is 0. Okay. 0 and 1 is 0. Again, 0 and 1 and 0 is 0. And the last case is 1 and 1. Okay, 1 and 1 is 1. In case of OR, 0 or 0 is 0. The only possible result 0 can be obtained if and only if two of the operands are false or 0. So in this case, A and B are 0. So for that purpose, OR will be 0. For the second case, 0 or 1 will be 1. 0, 1 or 0 will be 1. 1 or 1 will be 1 again. When you come to the third logical operator, which is not B, B at this moment in the first row is 0. So not 0 is 1 and not 1 is 0. This is how logical operators work. So to express this in terms of Java programming or the syntaxes of Java program, let's use two variables, which are, let's say, Boolean type variables, like first val, let it be true, and second one, Boolean type second val, let it be false. Okay. Now I want to compare or evaluate this using logical operators. So for that, let me put this inside the system.out.println. Okay. First, let me check first val and second val. Okay. And end is written in Java as 2%. First val and second val. In the second case, let me use OR. In the third case, let me use AND for the first val, okay, which is exclamation mark. So if we run this code, first val and second val should yield false because true and false is false. The second case, first val and second val with OR operator should yield true because if any of them are true, then the OR operator will yield true as a result. And not first val should yield the opposite of the first val, which is the opposite of true, which is false. Okay, let's run. So as you can see, for the first one, we have false. For the second one, we have true. And for the third one, which is not first val or not true, its result will be false. This is a very simple example to show how the three logical operators perform. The other most commonly used operator in Java is assignment operator. Okay. So assignment operator is basically equal sign that assigns a value to a variable. For instance, if we say int num is equal to 10 or some random value, then this is called an assignment operator, which assigns value 10 to a variable number. Okay. There are also other ways to use assignment operator, which is, for instance, one way, for instance, it would be, let's say, num is equal to num plus 10. Here, basically, we are using the same assignment operator, okay? But we are using the value of the previous or the current value of num and adding 10 to the current value of num, and then using the pointer or the reference to the place where num holds to update the result of the num. So this can also be written as num plus or is equal to, let's say, for instance, 10. These two operations have equivalent effect. So this num plus is equal to 10 means num is equal to num plus 10. Okay. So the operator that we are using here, in addition to the arithmetic operator here, is called the assignment operator. There are variations of operators in Java in addition to the assignment operator. The other type of operator here is the increment and decrement operators. So increment and decrement operators are there as a shortcut for adding or subtracting one exact constant value to your variable. Let's begin with declaring some integer value. For instance, let me call that integer value count, and let it start from 0. So you can simply say system.out.println, okay, plus plus count. The other possibility is system.out.println count plus plus. I'll talk about details of this, okay? The same is true for minus minus and minus minus count. Okay. So when we say increment and decrement operators, there are two types of operators. The first one is post increment or post decrement operators. Okay. And the second one is pre increment or pre decrement operators. The effect of these operators is different. For instance, there will be a situation in which the post increment yields different result from pre increment in the same variable. Let's say this one, for instance. If I say system.out println plus plus count, then the println function first updates the count value by 1 and displays 1 here in the first round. So I expect 1 here. Okay. In the second case, since it is post increment, count plus plus, it's post increment, we are using plus plus as a postfix, then the result will be reflected not in this statement, but in the statement next to this one. So here the result should be the same one, but count for the next statement is changed to 2, not for this statement. You will see the result. Now we have count value 2 for the third statement, count minus minus, it's postfix. So here the display will be 2 exactly, because this minus minus will not affect the value at this moment, but for the next one. It's post expression or post statement effect operator, which are post increment and post decrement. Okay, so here this is post decrement. So it will not affect the result of print line in this current moment, but it will affect this one. So the value of count at this moment will be, after this moment will be 1, which is decremented by 1. Then finally, we have a value 1 for count. Minus minus count yields value 0 because this is pre-increment. So in this same statement, you will get the effect of this operation. Okay, so the difference between pre-increment and post-increment, or pre-decrement and post-decrement, is that pre-decrement or pre-increment operations reflect their impact in the same statement that you are using them. But post-increment and post-decrement operators does not reflect their impact in the same statement they are being used, but in the next consecutive statement that will be using those variables which are incremented or decremented in the previous statement. So let's run this code. As I have already discussed, the value of the first one is 1, as you can see here. Since we used pre-increment, the effect will be shown in this exact statement, this very statement. But for the second statement, since we used post increment, the value of the second statement is the same as the value of the first statement because it's post. The count value is changed to 2, but the effect of this post increment will not be reflected in this very statement. The third one, we have a count value 2. For the third one, 2 is an input. So 2 minus minus, it's post increment. So for this specific code, it will not be reflected since we have 2 as a value of count. But for the next one, this count or this print line accepts a count value of 1, and pre-increment on 1 yields the exact impact that we are expecting at this exact or very statement. So the result will be 0. This is the phenomena or the mystery of increment and decrement operators. The last types of operators that I will be discussing today in this lecture video is bitwise operators. In Java, bitwise operators work on individual bits of integer types, like int, long, short. So here are the different types of bitwise operators. The first bitwise operator is called AND. Okay. The second one is OR. This is also, a bitwise operator, or like this single bar. The third one is XOR. XOR is like this. Okay. And the fourth one is NOT. NOT is represented with tilt. So just to clarify, bitwise AND is this one. Bitwise OR is a single bar. This one is bitwise XOR. Okay, XOR. You might recall this concepts from digital logic course or logic electric circuits course. Not operator is represented with a tilt. Okay, so we can define some more bitwise operators like XNOR, NOR, NAND, something like that one. Okay, but for now this will be enough. Let's define two variables, integer type variables. Let's say number one is equal to 5 and int number 2 is equal to 3. Okay, so first let's do bitwise AND, which is an AND operation with single ampersand, right? So to do this, system dot, just to display everything directly, system dot out dot print line, then number one, num1 AND, bitwise AND number 2, right? So what does it perform? It basically computes for the binary equivalent of these two numbers. For instance, for 5, we have 0, 1 like this. And this is equivalent to 5, as you remember from elementary classes. And for 3, for instance, we do have 0, 0, 1, 1. This is the binary equivalent for value 3. So it computes bitwise AND operation. 0 and 0, it will be 0. 1 and 0, it will be again 0. 0 and 1, again it will be 0. 1 and 1, it will be 1, right? From the previous class in this lecture video. So the result, for instance, if you display this one directly, you will get similar type of result. Okay, here you get 1 because it's like 0, 0, 0, 1. Okay, this is how the bitwise AND performs. Let's again do the same type of computation for the case of OR. Okay, number 1 or number 2. So in this case, for instance, 0 or 0 is 0, 1 or 0 is 1, 0 or 1 here for this case, for the third one, 0 or 1 here is 1, and 1 or 1 is 1. So the result will be 1, 1, 1. So let's again run this one and see the second result. So it is 7. The reason it says it's 7 is the binary equivalent for 7 is 0, 1, 1, 1. Okay, so it converts back to integer. It converts the integer, the binary, back to integer type and displays the equivalent value. This is how the bitwise OR operation works. Okay. When we come to the bitwise XOR, it's almost the same as I have already mentioned. It's number 1 XOR number 2. So it performs the XOR operation between these two, and it yields a result 0, 1, 1, 0. Okay, this is mainly due to the fact that 0 XOR 0 is 0, 1 XOR 0 is 1, 0 XOR 1 is 1, and 1 XOR 1 is 0. So in case of XOR, basically, if the two values, if the two parameters have the same value, either it is false or true, then the resulting value will be false. Otherwise, if any of the operands have different value, for instance, if the first one has false and the second one has true, then the result for XOR will be true. And also, if the first one is true and the second one is false, the result will be true. Okay, so here the result will be 0, 0, 1. The reason would be 0 XOR 0 is 0, 1 XOR 0 is 1, 0 XOR 1 is 1, and 1 XOR 1 is 0. Okay, this is the basics of bitwise OR. If you see bitwise NOT, it inverts each bit of the operand, changing zeros to ones and ones to zeros. So let's do this by using the tilt operation in Java. Tilt number 1, like this. Okay, so basically this one should convert each value of or it should complement each value of the binary equivalent of number 5. So the result will be here 1, 0, 1, 0. If you run, you will get the same type of result. The result of this one will be minus 6 because 1010 is 6. But since we are complementing the positive number, it should be represented as minus. So the result will be minus 6. There are some more bitwise operators that we can discuss here. For instance, the first one that hasn't been commonly used is left shift, which is represented by two less than signs. This left shift basically shifts the binary equivalent of the operand to the left by the number of positions specified by the right operand. For instance, let's take number 1. So if we say, for instance, system.out.print, then number 1 uh, left shift by 1, then since we have discussed about the binary equivalent of number 1, which is 0101, then this operation left shift shifts the values or the digits of this number 1 variable to the left side by 1 digit. So that means we will get 1010 value. Okay, left shift, because we are shifting it by 1 value. The other type of operation here is the opposite of left shift, which is right shift, and represented by double greater than sign. So if we take, for instance, this same example from here, system.out.println, number 1 right shifted with 1 position, then the corresponding result for this one will be 0010, because we shift these 3 digits to the left by 1 position. So this will be discarded. This will be in the first position from the left, and this will be in the second position to the left. Okay. Before we dive into details through exercises, let's quickly recap. In our journey so far, we have laid foundation with arithmetic operators, and now in this specific video, we have been working with relational operators, logical operators, assignment operators, increment, decrement operators, and bitwise operators. Let's talk about the practical side of bitwise operators. How could we use bitwise operators in real-world scenario? The first application of bitwise operators could be for flag manipulation, in which we can efficiently set, clear, or toggle specific flags. Bitwise operations can also be used for data compression. And also, we can use bitwise operators for bit level parallelism, optimization, cryptography, and device control in system programming. All right, let's summarize what we have covered today. We have discussed about relational operators as an effective value comparison entities, logical operators as a way to construct intricate conditions. Assignment operators are also seen as a way to streamline your code. Increment and decrement operators as a way to provide handy shortcuts. And finally, bitwise operators for low-level bit manipulation has been discussed. Let's solidify our understanding with some exercises. Let's start with relational operators. Okay? Exercises. Let the first exercise be about declare two integers and compare them using relational operators and say print the result. Pretty simple one. If you understood what I have been discussing so far, this should be simple. So let me declare two integer variables like num1. Let's say these are some random value. Int num2. Again, let me give it some other random value. Now, according to the question, it requires me to compare them using relational operators. So there are various relational operators that I can use for this question. And finally, I have to print the result. So let me use the shortcut. Let me directly print out the comparison by using system.out.print. So the first comparison, let it be greater than. So num1 or num2 greater than num1. Okay. This is one scenario. Num1 less than num2, another scenario, less than or equal to could be another possible scenario. Greater than or equal to, another possible scenario, not equal to, another possible scenario, and also equal to could be used to compare between two operands. So if we run this one, we get Boolean values like true or false for each of the expressions here. So I consider the first question done with this. Exercise 1. Okay, let's commence exercise 2. The second exercise is about taking two strings as input and use a relational operator to check if they are equal. So take two strings. Just whenever I write this kind of pretty simple questions, I recommend you to pause and try it by yourself, okay? Take two strings as an input and use use relational operator. It should be equality operator to check if they are equal. So for this we use equality operator, right? But first I have to declare a string type variable. So var string 1 is equal to, say, hello world. Okay, let's declare another one, string var string, let me correct the naming for the previous one, string 2, let it be world hello, like this. Okay, now let me use the system.out as a shortcut to display my result of equality comparison. So this can be done by variable string 1, var string 1 is equal to var string 2. This is a basic comparison operator. So the last result belongs to this one. So it's false because hello world is not equal to world hero. So just to check this one here, for instance, let me change the answer to not equal to. It should yield true. Okay, so this is what I expected. Okay, let me comment this one out and dive into the third exercise. Exercise 3. Exercise 3 is about logical operators. So it says implement a program that checks if a student is eligible for a scholarship based on two conditions using logical operator. So implement a program that checks if a student is eligible based on two conditions. Okay. So let me randomly give two criteria. The first criteria should be his age should be greater than, say, 13. Okay. What should be the second criteria? The second criteria should be he must have grade more than, which is more than, say, 3.9. Okay. 3.9. Let's take these two cases. So in order to do this, we have to accept these inputs from the user. So let me say int age is equal to 13. Okay, or some random number, actually 23. He could be 23 years of age, and grade should be declared as double. So grade, let it be 3.7. So my intention is to check whether the student is eligible for scholarship or not according to the criteria that we have set here. So let me use the shortcut system.out .println, and here I will be using two statements. So for that, let me use parentheses. So the first condition is age greater than 13. It's end condition, right? And should be written with double ampersand in Java. And the second condition is that grade again should be greater than 3.9. Okay. So according to this example, if assume the first age greater than 13 is expression 1, and greater than 3.9 is expression 2. So the result for this AND operation yields true if both conditions are true. Okay, but in our condition, for instance, we have age 23 for the student. The criteria is to be more than or older than 13 years of age. So this will be true in our case. Sorry, true in our case. And expression 2 is greater than 3.9. The student's grade in this condition, in this case, is 3.7, so it yields false. So true and false is false, right? So let's run. Yeah, let me change the value of the student. Let's say the student scored 3.98, something like this one. So if we run this code, it should yield plus, like positive or true. Nice. So we are done with the third question. Let's pass to the fourth question. The fourth question is about logical operators. It is about writing a complex condition that to determine if the number is positive and even using the logical operator. So write a program to determine if a number is positive and even using logical operators. Okay, so here we have two criteria. One, number should be greater than 0 because it should be greater than or equal to 0. It should be positive, right? The second scenario, uh, number should be even. Mathematically, this can be computed as number modulo 2 is equal to 0. So let's compute this one. Again, I will declare some number, int number 1. Let's say it's 23. I love this number. And now let's use shortcut system.out.println. Okay, println. Then the first condition is to check whether the number is greater than or equal to 0. So greater than or equal to 0. Check this one. Second condition, use AND. It should be even. So for that, number 1 modulo 2 is equal to 0. So if the number is even and positive, then this will return true, otherwise it will return false. So this one returns false because even though the number is positive, it's not even, it's 23. So let's check by adding 1, making it even. It becomes true because it's both positive and even. Okay, let's go to the other exercise, which is about bitwise operators. It says perform a bitwise uh, and or operation on two integers and print the result. Okay, okay, this is pretty simple. So let me have two integer values. Let's say number 1 is equal to say 7 and int number 2 is equal to say some small number. Okay, so I will use system.out.println to directly display the result. First, let me display for AND operation. Okay, for bitwise AND operation. So I will use concatenation operator here, and the bitwise AND between number 1 and number 2 is displayed here, and bitwise OR is here. So bitwise OR between number 1 and number 2 is displayed here. So here I have to cast it to string. In order to cast bitwise operators result to string, we need to use integer dot to binary, since we are converting binary to string, binary string for both of these values. The same goes for the second one. Okay. Okay. This is already covered in the second video in this lecture series. Let's run this one. This returns the binary equivalent of this computation. If we convert this one, or if we put the result of these operations into some integer type, for instance, first result here, let it be for computation between bitwise and of those two numbers, and let's say second result here, or between these two numbers, and here we can use directly those variables. Okay. Yeah. Second result like this. So if you display this one, you'll get a different answer, not 111 or 100. Okay. The binary equivalent, the integer equivalent will be displayed here. That's all for the bitwise operator. Let me add one more exercise for augmented assignment operation. Okay, so let me rewrite the question as declare a variable and use augmented okay assignment. We have covered this one today. Operator to add 5 to its value. By the way, I'm just watching or reading the questions with you for the first time. Okay, so let's do this one. We have discussed about the augmented assignment operators, like for instance, plus is equal to, times is equal to, like this, right? The other one is for all arithmetic operations actually, modulo is equal to some more, like minus is equal to over or divided by something is equal to something like this one. Okay, these all are augmented assignment operators, but since we are asked to add number 5 to the declared and initialized value, we'll use the first option here. So let's declare one variable, number 1, which has a value, okay, let it be 10. Then I will be using augmented assignment along with the system.out.println. Okay, then here number 1 plus, okay, is equal to 5, right? The number required to be added is 5. So this will update the value number 1. Let's see the result. Yeah, as you can see here, the augmented assignment operation updated the value, which is 10 to 15. And that wraps up our journey through Java operators. We have covered a lot, from arithmetic and bitwise operations to logical and relational operators. Hopefully, you have gained a solid understanding of how these operators work in Java. We started by exploring the basics of arithmetic operators, learning how to perform calculations with numbers. Then we delved into relational operators, helping us make decisions based on conditions. Logical operators expanded our capabilities by allowing us to combine conditions in meaningful ways. Bitwise operators, in turn, took us to a lower level, manipulating individual bits for tasks like flagging and data compression. We even converted our results in binary strings for a visual representation. Increment and decrement operators provided shortcuts for modifying variables, making our code more concise and efficient. And of course, we couldn't forget about assignment operators, which play a crucial role in updating variables in new values. But guess what? Our learning journey doesn't stop here. In the next consecutive lectures, we'll delve into the fascinating world of control flow structures, specifically in Java. We'll learn how to control the flow of our programs, making decisions, looping through tasks, and creating more dynamic and responsive applications. Thank you for joining me on this exploration of Java operators. Get ready for the next exciting chapter in our Java programming series. Stay curious, keep coding, and I'll see you in the next video.